Okay, welcome to Motion, Forces, and Energy. This is the book we'll be using to learn about the basics of physics. So, if you go to page 8, I know I told you you had to find it, but we're going to on page 8 in our book, and I would like for you to notice all the elements on this page. We're in section 1 of chapter 1, what is motion? The chapter is called Motion and Momentum, down here at the bottom. You can't get it. And we notice what we'll learn. We're going to define distance, speed, and velocity. We're going to graph motion. This is very math related, and it's not difficult math. So it'll help you understand why you're doing some of the things you're doing in math. Why it's important that different motions of objects you see every day can be described in the same way. And we need to remember our units of distance, our King-Henry line, and then here's our new vocabulary. Okay, speed, average speed, instantaneous speed, and velocity. So, here we go. Alright, matter and motion. All matter in the universe is constantly in motion. From the revolution of Earth around the sun to electrons moving around the nucleus of an atom. Leaves rustle in the wind. Lava flows from a volcano. Bees move from flower to flower as they gather pollen. Blood circulates through your body. These are all examples of matter in motion. How can the motion of these different objects be described? Now, two things I think about when I read this are, one, these two comparisons. From the revolution of Earth around the sun to electrons moving around the nucleus of an atom. These two motions are the same because it is something revolving around something else. However, the Earth and the sun are huge, and the electrons around the nucleus of an atom are microscopic, electromicroscopic, tiny, tiny, tiny. The other thing I look at is I look at this word rustle, and flows, and move, and circulates. Okay, these are all what type of word? What part of speech? You're right. So, that type of speech, which I'll ask you about in class tomorrow, describes for us motion. Alright, let's look at our notes. Okay. Notice that we're going to have Roman numeral 1 for our big red heading. What is motion? We have capital letter A because we have a blue heading, matter and motion. Now, we do not have a level here because there is no little red heading. So you're going to write small a, and you're going to write that all matter is in motion. Okay, write this right here. All matter is in motion. Let me get down. I didn't use the red this time. I don't know if that's a problem. Is that a problem, Parker? I'm not sure. All right. Here we go. Changing position. To describe an object in motion, you must first recognize that the object is in motion. Something is in motion if it is changing position. It could be a fast-moving airplane, a leaf swirling in the wind, or water trickling from a hose. Even your school, attached to Earth, is moving through space. When an object moves from one location to another, it is changing position. The runners shown in figure 1 sprint from the start line to the finish line. Their positions change, so they are in motion. Okay, changing position is when an object moves from one location to another. Okay, did a very good job this time. Alright, so you have capital letter B, changing position, and you are going to write a little lowercase a when an object moves from one location to another. That is changing position. Alright. Now, we have a red heading here, so that's where our next level will come from when we do our outline. Relative motion. Determining whether something changes position requires a point of reference. An object changes position if it moves relative to a reference point. To visualize this, picture yourself competing in a 100-meter dash. You begin just behind the start line. When you pass the finish line, you are 100 meters from the start line. If the start line is your reference point, then your position has changed by 100 meters relative to the start line, and motion has occurred. Look at figure 2. How can you determine that the dog has been in motion? Okay, so what is the dog's position relative to the ball? How do you describe the dog's position relative to the ball? Now, these pictures have one problem with them. I want you to think about that and tell me what the answer is tomorrow. We talked about this a lot in class today, about reference points. Okay, tell your parents about what you talked about regarding traveling in a car. Relative motion. Okay, so here's our red heading. It is within the heading of changing position, so it is a number 1. And it is defined by moves relative to a reference point. And then, in parentheses, the way we understand this, it moves past something that is still. Okay, so it changes location relative to something else. Do you hear my squeaky chair? I know you do, Caleb. All right, here we go. Distance and displacement. Suppose you are to meet your friends at the park in 5 minutes. Can you get there on time by walking, or should you ride your bike? To help you decide, you need to know the distance you will travel to get to the park. This distance is the length of the route you will travel from your house to the park. Suppose the distance you traveled from your house to the park was 200 meters. When you get to the park, how would you describe your location? You could say your location was 200 meters from your house. However, your final position depends both on the distance you travel and the direction. Did you go 200 meters east or west? To describe your final position exactly, you also have to tell the direction from your starting point. To do this, you would specify your displacement. Displacement includes the distance between the starting and ending points and the direction in which you travel. Figure 3 shows the difference between distance and displacement. Okay? So here we have the boy, somebody has walked from here to here, from here to here. I don't know which way he's walking. I'm confused. Alright, well anyhow, he went this far and he went 40 meters. The displacement is 40 meters east. Okay, now because he's a very respectable fellow, he's not going to walk through the garden. He's going to walk 40 meters east and 30 meters north. Okay, his distance is 70, but his displacement is this length here, which is the square root of 2 longer than this distance, but you'll learn that in geometry. Northeast, and then this is, he goes all the way around. This is what we did in class today. He goes all the way around. He's walked 140 meters, but his displacement is 0. Alright, so we are number 2, because this is the second red heading underneath our blue heading. Distance and displacement. Distance is the length of the route you travel. Displacement is the end minus the beginning plus the direction. Okay, so we will work with this. It's kind of hard to put into words without having to write a whole lot down, but let's do speed, which you've written down, I'm sure, but you got to read about it because I'm going to ask you a question. Speed. To describe motion, you usually want to describe how fast something is moving. The faster something is moving, the less time it takes to travel a certain distance. Speed is the distance traveled divided by the time taken to travel the distance. Speed can be calculated from this equation. Speed in meters per second equals the distance in meters divided by the time in seconds. speed equals distance divided by time. Because speed equals distance divided by time, the unit of speed is the unit of distance divided by the unit in time. In SI units, distance is measured in meters and time is measured in seconds. As a result, the SI unit of speed is the meters per second. The SI distance divided by the SI time. That is a whole lot of talking just to tell you that speed equals distance divided by time. Distance equals rate times time is another way to look at it. But we'll talk about it in class. Okay, so you need to tell me to prove that you've read this. What's another way to say it? The other way is distance equals rate times time. Ha. Last one then. Okay, so capital C, because we are on a new blue heading. Speed is distance divided by time. The speed is also rate, R-A-T-E. That's what you know in math class. All right, good night. Get a good sleep, though. Caleb, Kyle, Vicka, Nick, and what's his name? Timmy. How do I stop? Good night.